Assalamualaikum and hi. So this is the example question of internal combustion engine cycle, chapter 2. So in this video, I'm going to show or explain the example of the Carnot cycle. So this is the example question of Carnot cycle. So the question is, show that the thermal efficiency of a Carnot cycle operating between the temperature limits of TH and TL is solely a function of these two temperatures and is given by equation. The efficiency of Carnot, thermal efficiency of Carnot equal to 1 minus TL minus divided by TH. So this is the TS diagram for the Carnot cycle. We have two isentropic process and two adiabatic process, and Q in from the heat source and Q out is the heat sink. So we know that the Carnot cycle is the efficiency of the Carnot cycle depends on the source of the heat source, which is in the Q in, and the heat sink at the Q out. Okay, from the question, actually, the question want us to verify the thermal efficiency of the Carnot cycle. So now we look into the TS diagram. Here is the TS diagram of the Carnot cycle, and from here, we know that area under the curve represent the energy for certain process. So let's say process 1 to 2, the area under the process is the energy of it, and I will explain it further. Okay, so first we look into the entropy value. We know that in state 1, the entropy is equal to state 4, and state 2 is equal to state 3. And as I already explained, S1 is equal to S4, S3 equal to S3, and from here we know that S2 minus S1 is equal to S3 minus S4. Okay, so from this equation, the area under the graph or the process is the energy for Q out, and the area under the curve is the energy for Q in, the overall energy. So as you can see here, the Q in and the Q out, Q in cover also the Q out. So in order to know the work net out, we should do something like that. So Q in should minus the Q out to get the work net of the Carnot cycle. The area inside the one which are colored by green color. So this is the work net out of the Carnot cycle. So from this, we know that Q out is equal to TL times in the bracket S3 minus S4, and the Q in is equal to TH time in the bracket S2 minus S1. And the work net of the Carnot cycle is equal to Q in minus Q out. So because we just want the work net of the Carnot cycle. So from the heat transfer equation, Q out equal to TL times in the bracket S3 minus S4, and Q in equal to TH time in the bracket S2 minus S1. And the net work is equal to W net equal to Q in minus Q out. And we can expand this equation and put the Q in and Q out equation in the work net equation, and the thermal efficiency, which is given as follow, equal to work net divided by Q in. We also can expand this equation to be something like this. And from this equation, we can see here the S2 and S3 divided minus S4 is replaced by S2 minus S1, because S2 divided by S1 is equal to S3 minus S4. So after we replace this equation, we can eliminate this and to be something like this. So from this equation, we can rearrange, and it is found to be 1 minus TL divided by TH, and this is the Carnot cycle of the thermal efficiency of the Carnot cycle. So this is the end of example question for Carnot cycle. Hope you find it useful, and hopefully you enjoy this video. Thank you.